All right, seventh grade. This is the intro to the design process. Design process, again, we kind of started talking about inventions and how things are created and what resources that we use. There's a process to go ahead and walk through when designing products. And so where does it begin? Well, think about where you start creating new products. It all comes from your head. It comes from the ideas that are in your mind. We have to sketch them out and create it on paper first and come up with that first step. Think about this. We've talked about how kids are creative, and I want to know how's creativity influence your design? Just walk back through when you're a child and you're creating the boxes, castle boxes made out of cardboard, making houses, making tunnels out of sheets. All those things come from your creative mind. So how does that influence design? Well, it makes things very uncommon. It creates brand new products that have never been thought of. So just being very creative is a huge part in design, and I think young kids have more of the creative ability than adults do, because as adults we tend to think corporate world and business, and we start to lose the creative edge. So you got to keep being creative as your middle school. Keep it up. Don't lose it. The longer you keep it, the better and more creative you'll be getting older. Now, what's the difference between engineering and design? We kind of talked about engineering. You create items to make them safe. So you're designing the items to make things look good, and the engineer's going to come by and make sure that they are completely safe. So when we design that nice chair, the comfortable chair, the designer might make it look really good, whereas the engineer is going to make sure it's safe for you to sit on and it's not going to crush on you. So again, we use the math, science to make it work, and then our designers will go through and make it look good. Now, I do want to talk about a term, ergonomics. Ergonomics is engineers going around and designing around the human body. An example here is an example of the armrest on chairs. It kind of helps you put your elbows. The back seat is higher than the other ones, than the top picture. There's a lot of different ways to have ergonomics in place. If you go to Walmart and look at the cashiers, they are standing on a big thick pad. That's an ergonomical product. It's designed to help the human body. All items that we look at, we try to design them around the human. Look at pop cans. They're the way they are to fit around a normal size hand. Now, you wouldn't make them too big because you couldn't hold on to them, or too small because then it'd be it wouldn't fit right. Look at the mouse, the keyboard. The mouse is designed around the hand. It fits perfectly in the palm of your hand. So all these, we design things around the human who uses them. Okay, what makes products attractive? Okay, these are what we call the design principles. There's a multiple of them, but we're going to talk about some of the common ones. We want to make sure everything's balanced. If it's symmetrical, everything is equal on both sides. So if you took this car and you cut it in half from the front to the back, the left side is going to look identical to the right side. That's symmetrical balance. Your body says that we have symmetrical balance, or formal balance, if you will. And there are another one that is informal balance, where it's not symmetrical. That is, you look at most newsprints and magazine articles; those tend to be informal balance. Proportion. Obviously, this car looks well proportioned. You do see some cars not designed, but people alter them to be proportioned different. If you look at some of those low-ride cars, people put the huge wheels on, and then on a little bitty car, it looks weird. Okay, it could be my personal opinion as well, but in graphics, it does look weird if something just doesn't fit. It's out of place. So proportion is a huge part in designing as well. Contrast. It's one of my favorite. If you can't see it, you don't purchase it. For example, go down to the Walmart aisle, the cereal aisle, and look at all the brands of cereals. All of them start to stand out with color, with pictures, bright reds and yellows, and this is contrasting to most kids. Okay, kids pick up on the bright colors, so the contrast is basically the difference between two items. So color, black, white. Frontenac colors are very contrasting colors. Big, little. So if you have something huge and something really next to it that's really small, they are very contrasting. Okay, it makes things stand out. And when they all work together to complete one good task and make something look really nice is what we call unity, working together. Okay, so when we get these designs, we want to evaluate them. This is more on the engineering side, but we typically create prototypes. You're going through the process now and creating a car, a paper car. That is a prototype of the final product. If you were to make a real car, obviously you'd use metal and other resources, plastics, but you would not use paper. So we are making a prototype so you can test out your idea. There's other ways to do this, is using programs on the computer. And the reason we do this is, obviously, if you're creating a building, you would not build a prototype building just to see if it worked. It'd be a waste of resources and money. So you would probably build the building on a computer and test it that way. Okay, because you might want to create a prototype of a bridge to span the Mississippi River. You would create it in a computer program and test it there instead of physically testing it like we were doing our paper cars. Now, this is something kids tend to do all the time. They always stick with their first idea. Why should you not stick with your idea? I know this is a question saying should you, but I'm going to tell you shouldn't. Okay, the reason is most people just think what's on the top of their head and not fully getting into the problem and thinking of all the best solutions. So you should never stick with your first idea because more than likely you're going to come across better ideas. Look at the cell phone, the iPhone. Why do they have iPhone 2, 3, 4, 4S, 5? Because they keep on improving the product. So you're always going to have something better that you create later. So try not to stick with the very first one. Okay, every solution once you come up with them should be evaluated and just keep refining your ideas and making them better as we move on. Okay, we want to talk about freehand sketches. Okay, freehand sketches, we use those in technology, and well, I think your slide stopped, so let's hold on one second. Okay, I think the PowerPoint got stuck. So, but why we use sketches in technology? Remember, we talked about the ideas in your head. We got to get your idea from your head onto conceptual design on paper. So we do a lot of freehand sketches to get our drawings on paper. We're going to do some sketching in class that looks similar to this, where you're going to kind of sketch out on some graph paper, just getting your ideas from your head onto paper, so then we can see what you're thinking of. Okay, a lot of times we draw and we're going to write down the size of it if you know it. Sometimes it's just a little sketch and you have no idea what size it is, but a lot of times we know I want a piece that's 12 inches long, 2 inches high, 3 inches wide, and we can go ahead and write those details down. Here's some sketches that are for electrical. We call these schematics. Okay, they're a little different. This is how electricians and electronics, they read their diagrams. Those lines are wires, and there's different resistors and diodes and so on, batteries, in these images, these little symbols. We're not going to go over all of those. We just want you to understand that there are different types of drawings out there for other industries, in which this one is the electrical industry. We are going to go over multi-view drawings. This shows what the object that you're drawing that looks like on paper in different views. If you notice, every item, not just the ones in class, but every single item that we possess on Earth has 6 different planes, 6 sides. You have a top, bottom, back or rear, front, left, and right. Most commonly, we have 3 sides that we're going to draw. And that is the front, the top, and the right view. That's what this looks like. Okay, so we're going to go and draw the front, top, and right when we draw our paper car. Okay, I hope you enjoyed the video. Take good notes. Keep watching it if you need to. Replay it, pause it, rewind it. Take good notes, and we'll have a quiz when we get back to class. Have a good day.